Nature is full of hidden wonders, but few are as mesmerizing as the rainbow garnet, a rare variety of andradite garnet that displays an otherworldly iridescence. Unlike traditional garnets, which are known most commonly for their deep reds and oranges, these stones shimmer with incredible bright spectral colors, much like the shifting hues of a butterfly's wing or an oil slick on water. But what gives these stones their hypnotic glow, and where in the world can they be found? Let's dive into the science, rarity, and untold story of rainbow garnet. To understand what makes rainbow garnet special, we have to look at the microscopic world inside the stone. The iridescence is caused by lamellar diffraction, a rare optical phenomenon where ultra-thin layers of the garnet's structure bend and scatter light, just like the microscopic ridges on a peacock's feather, or like the internal structure of an opal, creating its play of color. Unlike most garnets, which have a deep, uniform color, rainbow garnets contain microscopic layers inside their crystal structure. These are called exosolution lamellae, ultra-thin layers of slightly different chemical composition that formed inside the garnet as it cooled deep underground. These layers are measured in the nanometer range, so small that they're similar in scale to the wavelengths of visible light. When light hits the surface of a rainbow garnet, it doesn't just pass through it like it would in a normal gemstone. Instead, it interacts with these nanoscale layers, bending, scattering, and reflecting in a way that it splits the light into its spectral colors. But here's what makes rainbow garnet unique. The alternating layers inside the crystal have slightly different refractive indices, meaning they bend light at different angles. As light waves bounce between these layers, they interfere with each other. Some wavelengths cancel out, while others combine, creating vivid flashes of color depending on the viewing angle. This is what gives rainbow garnet its distinctive shifting spectrum of greens, purples, golds, and reds. Rainbow garnet is one of the rarest and most visually stunning gemstones on the planet, and its iridescence is a direct result of the unique geological conditions in which it forms. Unlike traditional garnets, these mesmerizing specimens are found only in a handful of localities worldwide, each with its own distinct characteristics and history. The iridescent rainbow garnets from San Pedro Mountain, Santa Fe County, New Mexico, formed within a classic skarn environment, where intense contact metamorphism between intrusive igneous bodies and surrounding carbonate-rich sedimentary rocks created the perfect conditions for their growth. As hot, mineral-rich fluids infiltrated the limestone host rock, they triggered complex metasomatic reactions, replacing the original material with a dense mix of iron, silica, and calcium. This process led to the crystallization of andradite garnet, but what makes these specimens truly unique is their ultra-thin lamellar growth structure engineered by nature to diffract light, creating their spectacular rainbow iridescence. This rare interplay of heat, pressure, and chemical exchange in a skarn system gave rise to some of the most visually stunning garnets in the world. For years, San Pedro remained a relatively obscure locality, known primarily among mineral enthusiasts and local collectors. The deposit was never extensively mined on a commercial scale, as the iridescent material is scattered in small pockets and difficult to extract in large quantities. Additionally, the extreme fragility of these specimens due to their thin diffraction layers makes them challenging to work with. However, the unparalleled vibrancy of color produced by these garnets, featuring electric blues, greens, purples, and golds, has made them some of the most sought-after examples of this rare phenomenon. In recent years, renewed interest in rainbow garnet and its optical properties has brought fresh attention to the San Pedro deposit. While material from this locality remains scarce, efforts are being made to study and preserve its significance. The locality is now considered largely depleted, with only occasional small-scale collecting taking place. Many of the finest specimens from this area reside in private collections or museum displays, solidifying San Pedro Mountain's reputation as a pioneering source of some of the most vividly iridescent garnets ever discovered. San Pedro Mountain is also where my journey with rainbow garnets began. Japan's rainbow garnets, discovered in the Tenkawa region of Nara Prefecture, are among the most famous and historically significant sources of this rare optical phenomenon. The geology of this locality is distinct from the other deposits, with garnets forming within altered skarn environments influenced by volcanic activity. What sets Japanese rainbow garnets apart is the thickness and structure of their diffraction layers. Unlike the ultra-thin lamellar structures seen in garnets from New Mexico or Nevada, which create intense but fragile iridescence, the Japanese material features more robust, multi-layered diffraction bands. This makes them far easier to facet, as their optical layers maintain integrity even when cut. Most specimens from Japan exhibit a sheen-like diffraction, where the iridescence appears as a soft, glowing luster, with layers of uniform color. However, when these garnets are faceted, cutting through the multiple layers can reveal a stunning interplay of shifting colors, unveiling hidden flashes of vibrant greens, purples, and golds as different diffraction planes are exposed. This unique structural characteristic makes Japanese rainbow garnets particularly desirable for gemstone cutting, allowing lapidaries to unlock a dynamic spectrum of color that changes with every angle. The history of the Tenkawa rainbow garnet deposit adds to its mystique. First documented in the late 20th century, these iridescent garnets quickly gained international attention for their rarity and optical effects. However, the deposit was never commercially mined on a large scale, as the material was found in relatively small pockets within the skarn formations. Japanese collectors and researchers took great interest in these specimens, leading to their preservation in museums and private collections. Due to the limited availability and environmental protection laws, access to the original mining areas has become increasingly restricted, making high-quality Japanese rainbow garnets even more sought after today. Their legacy remains a testament to Japan's deep appreciation for nature's artistry and its dedication to preserving rare mineralogical wonders. Deep within the Arlit region of Niger, in the heart of the Sahara Desert near the Algerian border, lies one of the most spectacular and newest sources of rainbow andradite garnet. Unlike the skarn-hosted garnets from Japan and New Mexico, the Niger material formed under unique metamorphic conditions within altered iron-rich sediments. This distinct geology has given rise to some of the brightest and most metallic diffraction effects ever seen in rainbow garnets, with colors that appear almost electric, featuring intense flashes of gold, green, blue, and violet. The thicker diffraction layers in these specimens make them far more durable than the delicate material from other localities, making them highly desirable for faceting, while still maintaining their exceptional optical qualities. Discovered in 2021, Niger's rainbow garnets represent the most recent major find of this rare phenomenon. The deposit was uncovered by artisanal miners who initially overlooked this material while searching for uranium and other minerals. As awareness of its unique optical properties grew, Niger's rainbow garnets quickly gained recognition in the fine mineral and gemstone communities. However, the deposit has proven to be extremely limited, with fewer than 50 kilograms of this extraordinary material ever extracted, including large matrix pieces. Due to the region's harsh desert conditions, political instability, and uncertain resource availability, it remains unknown whether additional material will ever be found. Tucked away in the rugged, mineral-rich terrain of Nevada, the Rainbow Mine is a historic and largely forgotten source of iridescent andradite garnet, the very first documented discovery of this rare optical phenomenon. Nestled within a skarn environment, these garnets formed through complex metasomatic processes where iron and silica-rich fluids interacted with surrounding carbonate rocks. Similar to the material from San Pedro Mountain, New Mexico, the Nevada rainbow garnets exhibit stunning diffraction-based iridescence caused by ultra-thin lamellar structures within the crystal. However, the garnets from this locality often feature unique structural variations, with some specimens displaying more pronounced diffraction effects and higher durability compared to their New Mexico counterparts. First discovered in the late 20th century, the Rainbow Mine briefly captured the attention of mineralogists and collectors before fading into obscurity. Unlike other garnet deposits, this locality was never commercially mined, and only a handful of specimens were ever recovered. For decades, its significance remained largely unknown, overshadowed by the more widely recognized localities in Japan and New Mexico. However, recent efforts have begun to revitalize interest in the mine, with new exploration aiming to uncover more of these remarkable iridescent gems. What makes the Rainbow Mine particularly exciting is its potential. As the first documented source of rainbow garnet, it represents an untapped opportunity to further study and collect this rare phenomenon. While the deposit remains largely unexplored, its rediscovery makes an important step in preserving the legacy of Nevada's rainbow garnets. If new material is successfully recovered, it could provide invaluable insight into the formation of lamellar diffraction garnets, adding yet another layer to the fascinating story of this natural optical wonder. Located 200 kilometers southeast of Hermosillo, Mexico, deep in the Sierra Madre near Alamos, the Sonora Rainbow Garnet deposit is one of the most enigmatic and elusive sources of iridescent andradite garnet. Sometimes referred to as Acroy Ray Mine, this obscure locality was first documented in the 1980s. These garnets formed in a classic skarn deposit where intense contact metamorphism between igneous intrusions and carbonate-rich sedimentary rocks created conditions for their crystallization. Mining at the Sonora locality was always small-scale and artisanal, with specimens collected by hand from the surface float and shallow diggings. The mine was primarily commercially productive between 2004 and 2005. This locality was largely exhausted shortly after this time. By the time Japan's Rainbow Garnet deposit was discovered, Sonora had already faded into obscurity, with only old stock in private collections and the mineral market preserving its legacy. New specimens from this region are virtually unheard of today. With no further mining activity and no confirmed new discoveries, Sonoran rainbow garnets remain an exceptionally rare and historical chapter in the world of fine mineral collecting. Beyond the well-documented sources of rainbow andradite garnet, there exist a few obscure and little-known localities in Drammen, Norway, and Inner Mongolia, China, where this rare optical phenomenon has also been observed. In Drammen, garnet-bearing skarn deposits have produced occasional specimens with iridescent diffraction effects, though the material is extremely scarce and has not been widely studied. Similarly, in Inner Mongolia, a few reports have surfaced of andradite garnets displaying weak to moderate lamellar diffraction, though these occurrences remain largely undocumented outside of private collections. Among the rarest optical phenomena found in rainbow andradite garnets, asterism and chatoyancy elevate these already spectacular gems into an even more extraordinary category. While the dazzling iridescence of rainbow garnets from San Pedro Mountain, New Mexico, Sonora, Mexico, and Niger is well known, a select few specimens exhibit an additional interplay of light, manifesting as star-like reflections or silky bands that shimmer across the surfaces. These effects are not caused by traditional inclusions as seen in star sapphires or cat's eye chrysoberyl, but rather an intricate interaction between the garnet's lamellar diffraction structures and internal crystallographic features. This makes their occurrence not only unique, but exceptionally rare. Asterism, appearing as a mesmerizing four-rayed star, emerges when light scatters over precisely oriented diffraction layers within the garnet. Chatoyancy, or the cat's eye effect, results from similar structural alignments producing a luminous shifting band of light across the gem's surface when properly cut and polished. These effects are only seen in an extremely small fraction of rainbow garnets, making them some of the most sought-after collector's pieces. The interplay of iridescence with these rare optical phenomena creates an almost supernatural display of color and movement, solidifying these garnets as some of the most fascinating and elusive gemstones in the world. Rainbow garnet is one of the most visually stunning yet underappreciated gemstones in the market, prized for its spectacular diffraction-based iridescence rather than traditional body color or clarity. This phenomenon caused by microscopic lamellar structures within the crystal makes it one of the most unique natural gemstones available for jewelry. However, due to its delicate iridescent layers, cutting and polishing rainbow garnet requires precision and skill to maximize its optical effects. Faceted and cabochon cut stones typically range from 100 to 1,000 per carat, depending on quality, color vibrancy, and size, placing it within the reach of collectors while still maintaining an air of exclusivity. Because of its rarity and limited availability, rainbow garnet is seldom seen in mainstream jewelry stores, but is increasingly sought after by bespoke jewelers, high-end lapidaries, and collectors of rare optical gemstones. With growing appreciation for natural phenomena and gems, rainbow garnet has the potential to become a more prominent player in the world of exotic gemstones, offering a truly one-of-a-kind visual experience that no synthetic or treated stone can replicate. Though rainbow garnet remains a niche gemstone in the fine jewelry market, it is gaining recognition among high-end designers and collectors seeking unique, natural phenomena that rival the beauty of opals or rare color-changed gems. Artisans carefully select material that preserves the diffraction layers, often shaping stones into smooth cabochons or precision-cut facets to enhance their prismatic effect. Thank you for joining us on this journey into the mesmerizing world of rainbow garnets, a gemstone like no other, where nature's artistry meets light in a dazzling display of color. These rare and extraordinary gems embody the perfect fusion of science, beauty, and rarity, making them a true treasure for collectors and jewelry enthusiasts alike. At Isometrica, we are dedicated to uncovering, preserving, and sharing the wonder of these iridescent masterpieces, ensuring their story continues to inspire. We invite you to connect with us, explore our collections, and be part of this evolving discovery as we bring the brilliance of rainbow garnets into the world of fine minerals and jewelry. Your curiosity and passion fuel our mission. Let's continue this journey together.